Good evening everyone. So today we are going to cover some problems based on exponential and gamma distribution. Both are continuous distribution. So the first problem says that the data collected follows an exponential distribution with this mean value. You need to find the probability that duration of a particular rainfall is at least 2 hours. Yes. Now before that, recall what is exponential distribution and what do you require for exponential distribution. So its PDF is given as follows: lambda e raised to the power minus lambda x. Then this is CDF, expectation and variance. Now one quick observation is, if you use PDF then you need lambda, but what is given is mean value, which is expectation x. It means 1 by lambda is given to be 2.725. So from there you must compute lambda to be 1 by 2.725. Now it's easy because now probability of x greater than equal to 2 is same as 1 minus probability of x less than 2. You have CDF, so 1 minus and 1 minus e raised to the power minus lambda, which has already been computed, multiplied by 2. So this is the required answer. Similarly, we can compute at most 3 hours and in between 2 and 3 hours. So computations are quite easy. You can see the answers by yourself and match the answer. The next one says that you have given a density function and standard deviation. You need to compute parameter lambda. So try it by yourself. Once standard deviation is given, it means you need to compute it. So standard deviation means first you need variance x, which is expectation x square minus expectation x whole square. So let's compute expectation x, which is integration x fx dx, which is minus infinite to infinite, lambda by 2, 0.5 is 1 by 2, then x, then e raised to the power minus lambda mod x and dx. Now one way is that you can kill a lot of time in computing the expectation x. The other way is that you can use some mathematical results. So x is an odd function, exponential is always positive, so it's an even function. Odd even becomes odd function, and integration of minus a to a for an odd function is always 0. It means your variance x would be expectation x square only, which is lambda by 2 x square e raised to the power minus lambda mod x dx. Now x square is even, exponential function is even is even. So when it is an even function, then integration minus a to a becomes 2 times 0 to a. So 2 times 0 to infinite, lambda by 2 x square e raised to the power minus lambda. Now for the limits 0 to infinite, mod x becomes x only, it's positive, and dx. So quickly try this integration by yourself. It comes out to be 2 by lambda square. Now you need to equate it with 40.9 whole square, because standard deviation is 40.9, and from there you will get the value of lambda. The next part shows you a system, and it says that if one component fail, the entire system fail. This is first information. The other one is each component has a lifetime which is exponentially distributed. Second information. And components are independent. Third information. Then AI is defined, which means ith component lasts at least t hours, means its lifetime is at least t hours. X is time at which system fails, which means shortest lifetime among 5 components. If one fails, the system fails. So that's why you take the minimum of the lifetimes of all the systems. The first part asks, the event is equivalent to what event involving A1, A2, A5? Yes. So one event is x greater than equal to t, and the other event would be, think, A1 intersection A2 intersection A3 and goes to A5. This makes sense because the event x greater than equal to t says that the lifetime is at least t, and it means it fails after t hours. So if A1 fails after 5 hours, this fails after 8 hours, after 3 hours, and so on, then what you do? You take their minimum. It means you take the intersection of their lifetime. This is greater than equal to 5, this is greater than equal to 8, greater than equal to 3, and so on. So you take the minimum. So that gives you A1 intersection A2, so on intersection A5. Once you have this information, then you can compute probability of x greater than equal to t. Try it by yourself. So x greater than equal to t can be written as 1 minus probability of x less than t, which is, if you compute probability of x less than t, it is, or better to write, this is same as probability of A1 intersection A2, so on intersection A5, and you have given they all are independent. So this becomes probability of A1 multiplied probability of A2 and multiplied so on by probability of A5. So first try to compute probability of AI. What is AI? Ith component lasts at least t hours, which means the lifetime is at least t, and what lifetime follows? Exponential distribution, which is 1 minus lifetime is less than t. So this becomes the CDF for exponential distribution, which is 1 minus e raised to the power minus lambda, which is 0.01 and t. So it becomes 0.01 t. Now probability of x greater than equal to t would be the product of probability of AI, A1, A2, A5, all are same. That's why it becomes e raised to the power 0.05 t. You multiply all of them. And now if you have to compute probability of x less than equal to t, which is f of t, you differentiate it. So this gives you, you compute it as 1 minus probability of x greater than equal to t, which is 1 minus e raised to the power minus 0.05 t. Now from here, if you compute PDF, you differentiate it with respect to t, that gives you 0.05 e raised to the power minus 0.05 t, which is of course exponential distribution lambda e raised to the power minus lambda t. So exponential distribution with parameter 0.05. So x follows an exponential distribution with lambda equal to 0.05. So very interesting question. So you can see the answer in detail. The next question is again very important question. It says that a radio telescope captures signals in a Poisson process at an average rate 144 per day. The other information is, if it is known that first such signal will be captured between 5 and 10 hours, What is the probability that first such signal will be captured in less than 8 hours? Yes, so this first such signal is a very important word here, because Poisson is a discrete distribution, but when first signal get captured, so that time is a continuous distribution. So there is a one result which says that if y is Poisson random variable, alpha is mean number of events per unit time, t is random variable denoting time till the occurrence of first Poisson event. So till first such signal will be occurred, means once when that first signal happens, that follows exponential random variable with parameter alpha. So first see what is alpha here. Alpha is 144 per day, but our unit is in hour. It means 144 by 24 per hour, which is 6. Yes. So now the required answer is probability of what is probability that first such signal will be captured, so x less than 8, given that 5 less than x is less than 10. Yes. So if you take their intersection, because recall that probability of A given B is probability of A intersection B divided by probability of B. So if you take their intersection, it becomes 5 less than equal to x less than equal to 8 divided by 5 less than equal to x is less than equal to 10. Now x follows exponential distribution with parameter 6. So that's why this becomes 5 to 8, then lambda, which is 6, e raised to the power minus lambda t 60 dt divided by 5 to 10 6 e raised to the power minus 60 dt. Now rest you can solve it further, and that gives you the required answer which you can match here. So very interesting question, how Poisson and exponential everything comes into the picture. If you go to the lecture slide, you will see that this result has been discussed there. So this is the last question, which again talks about a new thing, which is incomplete gamma function. So first recall, this is the PDF for gamma function, which has two parameters alpha and beta, and if you take beta equal to 1, it becomes standard gamma distribution. Now result says if x is standard gamma distribution, then its CDF is incomplete gamma function. Even the more accurate result which we are looking for is, if x has a gamma distribution with parameter alpha and beta, then its CDF, probability of x less than equal to x, can be written as f x by beta alpha, where this f is incomplete gamma function, and we have a table for incomplete gamma function. So using the table we can compute these values. So if x is gamma random variable with this parameter, we need to find this probability, which can be written as x less than equal to 20 minus x less than equal to 12. Yes. So now this would become capital F and then x by beta, so 20 by 4 and alpha, which is 8, minus 12 by 4 and 8. Recall the previous slide. So it means here f is incomplete gamma function with parameters 5, 8 and parameters 3, 8. Using the table you can get the required answer. The next part is x is gamma with mean and variance. and you need to find the upper bound. So you need the mean and variance for gamma random variables. So mean is alpha beta, which is 4, and variance is alpha beta square, which is 8. If you divide, then beta comes out to be 2, and substituting the value, alpha comes out to be 2. Now this is probability of x less than 10 minus probability of x less than 5, which is using incomplete gamma function becomes 10 by 2 and 2 minus f 5 by 2 and 2. Now if you see the table, then the only issue is that in the table the parameters are considered for incomplete gamma function, the parameters are integers, and 5 by 2 is not an integer, and that's why we are looking for upper and lower bound. So f2 comma 2 would be less than f of 2.5 comma 2 would be less than f of 3 comma 2. This you can see from the table. So this is 0.594 and this is 0.801. So from here you can get the required upper and lower bound, which you can see here in the answer. The last part is x is chi square with 6 degrees of freedom. So again you need to recall chi square, and you will see that for chi square beta is always fixed, it is 2, and alpha is degree of freedom divided by 2, so 6 by 2, which is 3. So now this probability can be computed, which is x less than equal to 10 minus x less than equal to 4, which becomes f53 minus f23. Using the table we can see all these values and have the required answer. So that's all from today's class. Thank you.